All right. So today I've got, maybe it's a treat. It's the culmination of everything that we've been talking about over the last few semesters, and I'm kind of just giving it to you guys. At least the starting template. There's still a lot that needs to be done in order to make this game. Now, personally, I love RTS games, so that's what we're leaning towards here. Originally I was going to have this person do its own thing, but I don't want to. Too much time. What we're going to do is we're going to take these four and we're going to have them go places. So like if I left click, you can see we do a blue line, and on right click, I do a red line. So I want to be able to have a blue line to move them over there, and then a red line to attack. Now the purpose of today is to cover state machines and enumerations and animations. You know, all the stuff that we've been working on really. It should just be like massive review, but with some extra added detail. That being said, let's go straight into it. The first thing we need to do is we want to raycast and get them to move towards it. So raycasting I've already given to you, and you can find the starter code for this in the comment section. There will be a Git link as well as a Unity project file, so you can download this and actually use this in any project as long as it is URP. You can use these assets. Cool. Okay, so first thing we need to do, we need to get our monsters to move. Now, I've created some scripts to get us started here. We have the commander script, and the commander script is kind of like our player. In our commander script, we have our attack and our move to, and our move to is the one that's drawing our blue ray. All we want to do is raycast, so physics, raycast, and we're going to raycast based on our ray here. That's why it's called a raycast. And then we're going to raycast hit, our hit object, with a distance, and then finally a layer mask. Now, we haven't talked a whole bunch about layer masks. We did mention them. The idea behind a layer mask is very, very similar to all the binary we've been talking about. Why look at a number as 1010, which is 10, when you can look at it as players, walls, bullets, enemies? You know what I mean? So what we're doing with a layer mask is we're taking all this information and then we're comparing it against the thing that we've actually hit and determining if that counts or not. If it counts, we return it, and if it doesn't, we continue. That's what a layer mask is doing. So, well, that's not true, but that's around what a layer mask is doing. That's the idea. It's only going to return things that are belonging to the proper layer. Let's go to our project. In our project, make sure that your monsters have appropriate layers. So edit their prefabs, make sure your friendly monsters are set to be players, and your enemy monster is set to be an enemy. Okay? Also, change the ground to be ground. Now, the kind of another thing that I really want to talk about is this idea of static caching, and this is going to come up next week on the optimization video, because apparently optimization sells like drugs. So what we're going to do, we're going to create a static utilities file, and this is just like my favorite file. I love these. In our static utilities file, we're going to delete start and update. We're going to delete these two up here. We're going to delete this, and we're going to make it a public static class. Now, a static class is a class that does not exist. It is purely for utilities, and there's a bunch of really, really cool tricks you can do here. Ask me nice enough, maybe I'll show you. But what we want to do is we just want to pre-cache our variables so we can use them later and not have to recalculate everything again and again. What I mean by that is we have something called layer mask, layer mask dot name to layer, where we can convert a name to a layer, and that's really easy. That's great to work with, right? Makes our life easier. And then we just plug that into here. But if we were to calculate that every frame, that would suck. So let's do this in static utilities. We're going to have a public static read-only int that's going to be called player ID, and give it a value of layer mask, name to layer, player. Duplicate it twice with Control D, and we have enemy layer. Rename these variables a little more appropriate. Layer, let's do ground as well. Ground layer. There we go. Enemy. And if you're in Writer and you do this, you can see that everything just shows up. It's fantastic. I love Writer. And next, we're going to do our public static read-only int, and it's going to be our This is going to be our raycast hit check. So move layers, and we're going to set it equal to player ID and the enemy and the ground layer ID. Okay. Now, why did I do that? Good question. That's because if we are thinking about this in the sense of binary, then we have 1, 0, 0, 0, 1, 0, and 0, 0, 1, just per se, and these are all of our numbers. The OR operator, one of them, means that what we are doing, instead of adding them as if they were numbers, which is like 4, 2, 1, you are combining them as if it was like this. Okay, and then your final output would actually be 7, which is the same as adding them all together. So no, it does not matter in this case. But it would matter in a situation where if one of them was like this. So if we had 1, 1, 0 and 1, 0, 1, the OR operation, one single OR, would return us a value of 1, 1, 1. That's the difference. It just looks at both of them. If there's a 1, it's a 1. If there's a 1, there's a 1. If there's a 1, there's a 1. That's it. Honestly, it doesn't matter. You can say plus as well. It's fine. Yeah, I'm going to do the binary operation because we should be thinking in binary here. And this actually brings up another issue. Named layer is going to return us the number of the layer index, returns the layer index, which could be something like 6. 6 is 1, 1, 0. That's not like proper binary terms for us. That would be 2 different layers. So we need to make sure that we're checking it like this. And now it's in proper binary form and ready to go. Let's head over to our commander where we can finally say static utilities dot and then our layers, move layers, just like that. Now, raycasting returns true or false whether or not you hit something. So let's say if we did not hit something, then return. Okay, if we did not hit something, return. But if we did hit something, then let's command all of our enemies, or not all of our enemies, but all of our controlled monsters, which is just an array that I created for us. It's lazy, I know, but if you're going to make this game fully, you do that on your own, okay? I'm not doing everything for you. For each monster that we have in our array, let us ask our monster to move to target, and it's going to be our hit object. That's it. You can go more complex with this, but that's all I want to do for now. Let's generate this function, but before we do, hit object dot points. There we go. Move to target, whatever hit object point. Fantastic. What we want to do is we have access to our AI nav mesh controller, so let's just say AI dot set destination, hit object points. That's it. Nothing going on there. Okay, it has loaded, and now we can test if our logic is correct. So I can right click, or not right click, but left click, and you'll see that they all move there wherever I press to. Lovely stuff. Now they're not animated, and that's kind of cringe, so let's add animations. This is kind of where animations get crazy, and unfortunately I've left stuff in there from the previous time. Go to your working anims folder and press on the monster animator, and this is actually going to animate both of them at the same time. They both have the same animation set, so this works. Consider this, if you're making like a fighting game, for example, you might want your characters to have the same animation set because it would save you a lot. Like Brawlhalla, for example, probably only has like 4 different animation sets, and then that's it. Anyways, so what we can do is let's create a state from new blend tree, and let's call this movement. Okay. Then let's open up our movement tree just by double clicking it. On the left side, we have parameters. We have layers and parameters. So in the parameters tab, we need to add a bunch of parameters. The first parameter that we want to add is going to be our x speed. Then let's add another, which is a float, and it's going to be our y speed. Okay. Change the blend tree by clicking it and pressing on blend type to Cartesian. And now we're going to change this to be y speed. So we have our x speed and our y speed, and let's put them both to 0. Now what we need to do is if you open the moving folder, we got so many animations we need to put in here. So I believe it was 9. 2, 3, 4, 5, 6, 7, 8, 9. And then you start chucking things in. Now don't worry about the idle ones, we're going to come back to this. We're going to do run back, run forward, run left, run right, sprint forward, walk back, walk forward, walk left, walk right, and we need one more, except this last one that we're going to add is going to be a blend tree. And it's going to be called, you can see it down here, press it, and we're going to name it idle. And we're going to talk about this in a moment. Great, okay. So we've got all of our animations. I like to sort them by what they are. So I like to keep my left with my left, my right with my right, my forward, walk forward, run forward, and sprint forward, and then walk, run back. I don't care about the order past that. I just like having them together. And then what I'm going to do is I'm going to configure them. So walking backwards is going to have a x of 0. Let's actually change this from y speed, because in Blender we're moving, not in Blender, God, it's different in every engine, I swear. It's our z-axis, not our y-axis. So let's actually rename this to be z, because y is up in Unity. So we're going to move on our z-axis. Anyways, we have our walk backwards, right? And what we want to do is we want to set our walk backwards to be -1, and then our run backwards is -2, and our walk forwards is going to be 0, 1, 0, 2, 0, 3, and you can customize this, of course. If you want like the splits to be longer, so you have to like go faster to enter sprint mode, maybe you increase this to 5 and this to 3. Walking left is going to be -1, 0. Running left could be -2, 0. Walking right, -1. Sorry, not negative, but +1. This is going to be +2, 0. There we go. And then finally for our idle is just 0, 0. And then idle is going to have its own parameter. It's going to have a float, and it's going to be called idle state. And the idea here is we actually have 2 different idle animations. Let's add 2. And we have 2 different idles. And generally when you're making a game, you should have multiple types of animations. It'll give your characters life, and generally it's really easy to add. And this is also an excuse to show you guys something that you should know as well. So we have our animations, they're all in place. Fantastic. And now what we can do is we can test them over here. So when you press play, and there's this little red dot, and you can see what will happen as you drag it around. You see as we go to the left, and you go more forward. You also see that there's this blend here between them as you go in between. The character will interpolate and try to determine what they're doing. And what's even cooler is you can see how our 2 idle animations work over here. Oh, this is wrong. Make sure you change the parameter here to be idle state. Put it to 0. There you go. The idle animations don't appear to be working. If nothing's showing up in here, you can drag and drop a model in. There you go. Oh, thresholds. Turn off automate thresholds. One is 0, the other is 1. That's fine. Okay, and then what we want to do, let's open this back up. Just see, when it's on 1, he's like that. When it's on 0, it's like that. Perfect. So he's 2 different idle states. Great. Now, let's set up our animation and make sure that it's working. So in our character, let's go to our monster, and in here, we need to tell its AI to, well, animate. We need to do stuff with its animator. To do this, we can say my animator dot, and then set float, and then the name of the float that we want to set. So we have x speed, z speed, and our idle state. So we can say x speed and make sure the spelling is identical or it's just not going to work, and then some value. Let's actually put this in update though, because this needs to be happening every single frame. You could even put this in, I believe late update is commonly used for this kind of thing. But honestly, I'm not too sure. I do animation once in a blue moon. So we're going to say with our x speed, and then we're going to give it a value, which is going to be our AI dot, let's actually pre-cache this, vector3 velocity. That is going to be our AI dot velocity, and then we're going to say velocity and then our x. Duplicate this, z. Now, if you are in writer, then you're actually getting a warning here that's like, hey, you're being stupid. And if you're not, then skill issue, get good. So what we can do here is, again, pre-cache variables to make our lives easier. X speed and Z speed, they are things that you have to look up. Your computer has to find these every single time, every frame you want to move around. That's not ideal. So to fix this, we can go over to our static utilities, and let's say that this is going to be our animations, and this is going to be layers. Our public static read-only int, and then it's going to be our x speed anim id equals animator dot string to hash, and then you put in the name. Duplicate it and change it to Z. Capitalization because it's static. Let's do another one, and then it's going to be the idle anim id. And make sure that your spelling in Unity is absolutely perfect. It's called idle state, because if it's not, it's just not going to work. That's correct. Okay. So I'm going to head back to my monster script now, and instead we can say static utilities dot, and then our variable, which is just going to be x speed id. Let's copy this one over, and it's z speed id. There we go, and we're about to encounter another issue. So we got our guys, and they move, and you'll see, look, they're running, they're doing it. But why are they running sideways? That's strange. And how come when I press on the forwards, then they start to sprint normally, but if I don't press forwards, they aren't? Well, if you press on one of them and you read their x speed values and their z speed values, right, you can see that there's an issue. It's not reading in local space like we would interpret from here. It's reading in world space. So that's not helpful to us at all. We need to convert it. But before we do, let's take a look at our idle animations. We have no capability of swapping between them. So before we do, let's just talk about that. Really easy stuff, and if you are doing literally any job in Unity, you should know how to do this. The animator is a very, very powerful tool. What we're going to do is we're going to go over to our moving file with our animations. We have idle 1 and idle 2. And we're going to add, in the event section, a new event. It looks like I might already have one. I do. At the end here. It's called change idle state. Okay? And you're going to do this in both of them if you don't already have it. Right? And I go to my events. Here we go. Change idle state. And pretty much, this is at the end of the event. So when the event fires, and you can see as the ticker goes, when it reaches the end, it will fire, and we can ask it to do anything in our script. Now the deal is, the spelling needs to be identical. So over here, I'm going to make a public void change idle state. Okay, and our change idle state, what we want to do is change our idle state. So my animator, set float, and it's going to be our static utilities, idle anim state. And then what we want to do is we need to get a new state. So int new state equals, and then we're going to choose a random number, random.range from 0 to the amount of animations we have. In this case, we only have 2, so we can hard code it. Okay? When you hover over a random range, make sure it says int. If it doesn't say int, you need to cast it to an int like this, because you're going to get a float, and it's going to be silly. I guess this will cast it to an int as well, but you might have rounding issues, is what I'm trying to say. Anyways, this is going to give us a value 0 or 1, and that's going to be exactly it. That's going to work. And if you compare that to our animator, in here, we're looking for either 0 or 1. That's it. Another thing, and I forgot to explain this, is how do we get the character to move with our animations? When you press on one of the animations, you can actually read their data in the animation section. We have 2 core components here, loop pose and loop time. This is what's allowing them to actually move with their animation properly. If you want the animation to physically move them, though, and we're going to do this later in the second half of this, change the motion to be Mixamo hips, okay? And then on your actual object with your animator, make sure your root motion is applied. And that's how you can get the animation to actually move them. Now, you lose a bit of control doing that, but it also looks a lot smoother. And sometimes you have to. So I'll show you guys a situation later where that might make more sense. So at this point, change idle state is plugged in and it should work. And when I press play, oh, sorry, there is a rule to these events as well. The thing that is calling the event must be connected to the animator. So the monster has the script, the animator calls the event. That's the way it knows that the script exists there. But now look, you'll see that some of them are doing different animations than others. And that it makes them just feel like they're not all the same. They have more life. They have their own personality. You give them like 4 or 5 different animations, and then you'll start to see a bunch of variation. If you play a game like Total War, then you'll know 100% what I mean. Okay. So at this point, we've got one more thing that we need to do. We need to correct their movement. Now, the way I did this, I wasn't sure. So again, my students, please use ChatGPT. You are foolish if you are not using ChatGPT. This is the world we live in. I asked it a question. I understood that the issue was something to do with local and world space. Here's what it returned. Transform inverse direction. I didn't know that was a thing. So literally, all we need to do is we need to say our velocity equals transform, and then inverse transform direction. And now, this is also what I'm saying. It's like, you gotta be using the GPT. You don't abuse it. You understand what you're doing, otherwise you won't be able to ask it questions in the first place. But if you don't know how to use it, you're not gonna be able to do stuff. Or, I mean, it's just gonna take you like an abysmally long period of time that took me 10 minutes to do. But look, now they all work properly, and they will run to wherever they're going, and you'll see that if I point behind them, they'll slowly turn around as if they're like turning. There you go, great. This is part 1 of the tutorial done. Join me for part 2 if you want to keep practicing and actually adding state into this, but technically animations is a state pattern.